answer that. So let's start. I'll share my screen. Just a minute. Yeah. So is it visible, guys?
Yes,
Yeah.
sir, it's visible, sir.
So as Dakshan told about me, I am a computer vision engineer and a 2024 passed out from Triple IT Jabalpur. I am also an open source contributor and a member of OpenCV community, in which we are developing the OpenCV 5 that to be launched soon in some time. So my passion is about building new computer vision solution, like stand up for new problems and try to get that their solutions. So we will start with that. As you all know, you guys must be knowing about AI. How many of you know about AI? Can someone give me a brief introduction for AI? Yeah, Param. You can. Would anyone like to share? Yeah, Param and Sai. Anyone?
AI ஏங்கிறது ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ். இட் இஸ் அ மேன்மேட் திங்கிங் பவர் தான் வந்து ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் சொல்றது. வி ஆர் கிரியேட்டிங் சம்திங் அண்ட் யூசிங் திஸ்.
Yeah. Yes. Yes. Nice job. Nice job.
Yes, sir. It's
So.
actually a like it is similar to like human brain. So how we manipulate the human cognitive functions to make our task, just like that, we are
Yeah.
actually using the machines to automate to do some task. So that is referred to as the artificial intelligence, sir. So
Yeah.
that is what they
Great.
are also trying to convey, sir.
Yeah, great job, right? That's what it is. It is just like mimicking human intelligence. In one word, we would like to say is that mimicking human intelligence. So there are so many real world problem for that. As you guys must be knowing about autonomous vehicles, and not going that far, starting from the very basics. All of us use Instagram, so the recommendation system in Instagram, Netflix, everything. Have you guys must be aware of Google and Siri? They are all part of artificial intelligence. So artificial intelligence have some parts of it. One is machine learning, and we are gonna majorly talk about that. Machine learning have also some parts that is specific about some things like deep learning. So let's talk about that. Deep learning is the detailed model by which the artificial intelligence is trained to do a certain task. Just like so many things as I told you before. And deep learning have a part that is computer vision, which focuses on images, like learning through videos, images. That is a task of computer vision. So like it is for visual inputs, and that is just like eyes of the artificial intelligence. Artificial intelligence sees using that. So how does a computer vision model work? For that, there are some things with this step, that is image capturing. First we will capture the image, then for a particular model there are some parameters that we need to fix for that. It takes the particularly normalized or resized image, Then that part is called pre-processing, and major part is feature extraction. For each image, we extract some features. On based on those features, we do the interpretations, just like classifications, object detections. So this is the part of this is computer vision. So the major like basic tasks and widely used tasks are for image classification, object detection, segmentation, and facial recognition. So how many of you guys have heard about YOLO? Anyone? Yeah. Yeah, so YOLO is popularly known for its object detection techniques, and it is
Yes,
widely
sir.
used across the technologies like I would say autonomous cars. Some of the startups are going there. Can you name some? Anyone can name some? Any startup in the autonomous vehicle field? One is Tesla, another is Waymo, and some Indian startups are also going that, such as Sweat Robots. They are doing well in the field. So I'm talking about autonomous vehicles again and again because they are the emerging technologies and are doing well, and they are the future of world. They will capture the market. They will do well. So in any bigger application, these four are the basic things. Wherever you go, like facial recognition, like face-based attendance system, just click your picture and your attendance will be marked. These all are with facial recognition. Coming to the next part, I'll just like tell classification. I have some examples of this. So first image you are seeing is the cat. We have a model that classifies whether it is cat or not. That's the basic, like if anyone is going to start, this is the basic model that they usually trains. Everyone start learning deep learning and computer vision with that only. Next is the example of object detection. They are detecting and classifying both. So bounding box is detected for the target like cat and dog, and then they are classified. This is the part of object detection. And the lower image you are seeing is segmentation. In so many tasks, we need to segment the things. Just like talking about uh, my project, that was an autonomous vehicle. So what we were doing in that, we were taking the continuous video of road, the continuous frames. Then they were segmented. We were mainly interested in the road that is visible. On that, we were planning a trajectory and moving our vehicle. So as I told before, there are two basic core concept of computer vision and artificial intelligence. The major part is machine learning, in which machine learns a certain pattern for recognizing anything. Just like everything has its certain pattern. Like human have some certain pattern, animals have certain pattern, car have some certain patterns. So with the data feeding and model training, machine learning learn that patterns. Okay, if this pattern is coming, I'll classify it as class A, class B, or whatever the class is. It has some sub part that is deep learning. So initially, machine learning was not enough to capture all the features because every one of us know image is very detailed. As a computer vision engineer, you just don't see image as an image, but detailed features that contains a lot of information. So basic machine learning models were not able to do that. So in later on, nearly 2000 and 2005, it got famous, the deep learning, that we will train a larger model with the help of convolutional neural networks. Initially, they were artificial neural networks, so just like neuron system in our body. Like our body also have neural networks. They transfer information one to another. Initially, it was replicated like that, but they are machines. They don't work like that. So after a certain time, they forget some features. So convolutional network is majorly designed for processing images. So it moves a filter on an image, and every time it captures that features, store that, and then process that. With this logic, many models were built. You all over built with that. You must have heard of mobile net or Google net. They are working with that only. So currently we are using deep learning models. Yeah. So this is my project. I would like to show the demo of it. So were you able to see it? Hello.
Yes.
So uh, it was just a demo of our project. So like that is not so great, but it was a starting from our side that with a monocular camera and servo motors, Raspberry Pi. Have you heard of Raspberry Pi? You must be. And Arduino.
Yes, sir. Yes, sir.
Yeah. So
Yes, sir.
will you please tell a little bit about Raspberry Pi, anyone?
Okay, sir. It is actually a microcontroller, which is actually
Yeah.
we use for doing such electronic related task. So in that we actually connect the components based on programming.
Yeah, yeah. That's great, right? So
Yes.
that's what exactly we did. We coded the model, trained it, and we put the trained model in the Raspberry Pi because we cannot use the whole computer, whole laptop with that a little vehicle. So we put it in the Raspberry Pi. It was connected with the camera. Every image is coming. It was segmenting the road and detecting the angle of road, like how much to be turned. For after that value, it gives that value that servo motor detect that takes servo motor takes that value and turn according to that. So it is a case that if you are going to turn right, so that model gives positive value that is fed in the servo motor, and servo motor decided to move right. For the left, it is negative value. So based on that, we did, and there were a lot of challenges for that. You must be seeing a boundary near the road. That is because to make our segmentation more clear, more better, because at last we were doing with a small camera, so we don't have high quality camera, so that they can differentiate between reflections, right, light reflections and the actual road. So that's why segmentation model gives some issue. So we decided to use the boundaries, and that project was doing well. Like it was one of the great engineering projects as per the faculties of our institute. So that was a really good one. Yeah, that would be enough from my side. Anyone would like to ask anything or anything to be explained in detail?
Okay, so now the webinar is actually open for questions. So the students who are actually interested to ask any questions regarding the covered topics which were actually delivered by sir, they can you can actually ask.
Yeah. I would say that This might not be a detailed explanation, because after all it's a webinar of half an hour or like an hour. So it was just a brief introduction of everything. You can, if you want to ask, you can ask in detail. I tell you. Yeah,
Okay,
Google.
Hello, sir. I'm Gola from final year ADS.
Yeah.
Sir, you have said that YOLO is an currently we're developing a software. I think it's a live detection, right? Live detection of motion camera and computer vision. Am I right, sir?
Which one?
YOLO, sir.
YOLO
YOLO
is
request.
not only live, it can perform live. Like
How?
live is based on the speed of models detection. If it is matching the FPS of camera, then it is live, real time. If that is taking time, then it's not real time. So yeah, YOLO does pretty well, and it is a real time model. It can work up to 30 FPS, 25 or 30. If I'm not sure, but yeah, that works really well.
Okay, sir. Thanks, sir. Sir, and actually, so comparing to computer vision and YOLO, which can be performed in some cases like detecting objects in real time.
Yeah, I didn't get your question. Can you please pardon me?
In real time, which is very powerful in detecting objects.
Yeah.
Computer vision, OpenCV or YOLO.
Actually, YOLO is a part of computer vision. Computer vision is a field, not a model, and YOLO is a model that does the thing. And OpenCV also uses YOLO. YOLO is the state-of-art model for the detections. Computer vision is a field that comprises of everything: classification, detection. It is just a field of study, just like from which branch you are.
Artificial intelligence and data science.
You are from artificial intelligence and data science branch.
Yes, yes,
So, like artificial intelligence and data science is a course that
yes,
comprises of a lot of things, but not an actually working thing, not an actual model. Just like
yes,
computer vision is a field, not a
okay,
model that performs anything.
Puri.
And
Yes,
OpenCV is an computer vision library that is built by OpenCV. It takes a lot of models like YOLO for detection, and classification is done by Google Net, Mobile Net, and many other models.
okay, sir.
I hope you are clear with that.
Yes, sir. Yes, I'm clear.
Hello, sir. I'm Siddharthan
Yeah.
from first year AML department. What is the
Yeah.
difference between media pipe and YOLO, sir?
YOLO and media pipe. So media pipe is a detailed model. So media pipe also detects key points. Like majorly, you will see media pipe is known for detecting the key points. It has, like, if I'm not wrong, 468 key points, 3D key points for the facial features majorly. The major use of media pipe is for that, and YOLO is for detections. Media pipe can detect, but the purpose it was built was to detect the 3D key points of the face. For we usually take 2D image, so we don't know the real depth. What is the depth of, like, if you are seeing, you must be seeing my 2D video. So what is the depth of my ear from my head? So to get the 3D points, media pipe was built. That was built by Google. It is majorly for facial key point detection, and YOLO is for object detection, locating the object and classifying that.
Sir, if I'm not wrong, it is just like media pipe is just like a framework and YOLO is just like an algorithm. Am I right, sir?
But YOLO comes as framework as well.
Okay, sir. Okay, now I can understand.
Yeah,
Thank you, sir.
you're welcome. Anyone?
okay. Is there anyone who needs to ask any questions?
Yeah, Google. You can
Sir,
ask.
if our camera is under some, because some of security's camera may be low quality, and it could be
Yeah.
some will be in 480p or 720p. It may not have a good quality image, like good
Yes.
quality images or videos,
Yes.
right? Then
Yes.
how come we can recognize at that situation, sir? The
Yeah.
camera. Mm.
So one thing we need to understand is what is low quality camera and high quality camera. So low quality camera captures lesser pixel than the high quality camera. So lesser pixel means lesser information for the model to learn, but it is still distinguishable, and model are robust enough. They are trained with that data, so they are able to classify. Just YOLO is a lot of is in the a lot of discussions, so we will talk about that. Like YOLO is trained on a robust data in which the data from camera was also there, the data from high quality cameras from there. So it is robust enough to get the detection for any type of image.
So you were saying that already pre-trained in that model, so we can easily detect that objects, right?
Yeah, yeah. More diverse the data, more robust is the model.
If I'm creating a new data or a new object, then how can it would be recognized, sir?
So you are asking me to like you are asking about how can we create custom data set.
Yeah,
Yeah, so just like from any camera, you take a video, mark that object, that rectangle that is called bounding box,
exactly.
and you will store in a txt file the center of that bounding box and height and width and height. So the order will be x, y, w, h. X, y is the center, and w, h is the width and height. And then you will pass those images and their corresponding txts to the model. You can take YOLO V5 model or YOLO V8. They have mentioned in their GitHub repo. So uh, you can give that data, and the training will start with the steps mentioned there. You can train on it on any custom data.
Okay, sir. Sir, how come we can do gender classifications, sir? Like
Generic.
gender classification, yes, like male, female. Other than object direction, we can we classify gender classifications also?
Yeah, yeah, gender classification. Yeah, you can do.
How
You can
which will
like there are so many models there. You can search on internet, or if you want to train, you can take any classification model. Just give a data to that. Give a folder. This one is male, and another folder. This one is female. Reprocess that data according to the model's requirement, and then train that model. You will get your desired results.
okay, sir.
You
Thank you.
can take any model like Google Net, Mobile Net, Squeeze Net, Efficient Net, ResNet, anyone.
Okay, sir. Thank you.
Sir,
Yeah,
what are
please.
the main differences between the traditional computer vision techniques and the deep learning approaches, sir?
Yeah. So, how many of you know about edge detection? Detecting the edges of an image. Yes, you can say.
Yes, sir. Actually, we use this edge detection technique in image processing and CV techniques. So what we
Yeah.
do is we actually identify, as you said, we actually find the points in the digital image, sir. So when
Yes.
it comes
Yes.
to like brightness changes and also some other criteria, so we actually use this to accurately point out the points in order to sort out the things like boundaries of the objects, or also for image segmentation, and also
Yeah.
the other things like feature extraction, and for also object recognition, we actually mainly use this edge detection, sir.
Yes. So I'll take that example for the Siddharth's question. So if you know about edge detection, then you might know about Kenny edge detector. That is a filter running over an image and to get the edges. And another way is deep learning models. That is DexiNet. That is that gives more fine results than the traditional edge detection techniques. So in traditional techniques, we don't use deep models. We don't train that. We generally use filters or light models to get our results. But in deep learning, we train the model of like 100 layers, 150 layers, or more or less to get the data. So, what is the difference? What is the use of deep learning models? So, the K-NES detectors, like or traditional detection algorithm, are bound to some certain kind of data and are not that great in the results. Whereas we have an option to give robust data, diverse data, to make a deep learning model robust so that they can perform in any kind of data. Are you clear, Siddharth?
Yes, sir, I'm clear. And one more question, sir.
Yeah.
While using media pipe, it is using some points which is on our face, like eyes,
Yeah.
noses.
Yeah.
Basically, it calculates the distance between them, right? The distance
Uh,
between two different points.
Not exactly. Not exactly. Because for like when you're blinking, your eyes get closed. So it will not monitor the distance. But yeah, it uses some kind of this for the training. I am not aware about the detailed training of MediaPipe, but yeah, that is the case.
So now we clear. Thank you.
Sir, I'm
Yeah,
Vinci, second year ADS.
yeah, is it?
I have one question for you, sir.
Yeah.
In what ways does AI assist in managing industrial operations that evolved from Industry 1.0?
I didn't get your question. Can you please pardon me?
In what ways does AI assist in managing industrial operations
Uh,
that
how does
evolved?
how does AI assisting manage assisting managing the operations?
Yes, sir. Yes, sir. How does
Yeah.
AI assist in managing the industrial operations, sir?
Yeah. So I would say like uh, just just take with the security system. When you own a warehouse of a bigger company, then you need to monitor the things. Where are they? Is anyone like anything getting theft or not? Is everything on the place? So with the help of AI, now you can place the cameras. It will keep on running a model on 24 into 7 hour basis, and it will monitor any changes that is not good enough changes. If anyone enters, it will detect, capture its photo, and if anyone suspicious enters, it can keep the like details for that. We can connect it to the security alarm if unknown personnel, unauthorized personnel is entering that. So one of the key like major uses can be the security system, and like or we can see that is not a bigger example that I'm going to say that, but it is still that attendance system, monitoring. There are so many examples in that. Are you clear, Nancy?
Okay, sir. Thank you, sir. And I have another question for you, sir.
Yes, Amy.
How could AI have influenced Industry 1.0 if it had existed during that era?
Sorry, I didn't. Still couldn't get what you said.
Okay, sir.
Sir, actually, she is asking that how AI could have assisted during the proto-industrialization. So that is, she is referring to the Industry 1.0. If the AI is existing in that time, so how would it be assisting the industry? She is asking, sir.
Uh, with my personal thoughts, I would say the same way that it is doing it now. Like we, if AI existed at that time, we would have much futuristic than this time. Like we are getting on the same thing, but after some time, it would have assisted in the same way, I guess. And I personally think everything should take its own time. So, I would say it is the right time for the AI.
Okay, sir. Thank you, sir.
Yeah, Google.
Sir, can you please explain the how attendance system is working, the attendance system project?
Yeah, attendance system, like, just say you are a new user. What you will do, you will take your 5-10 photos and register in the class that I am a part of this class. And whenever, be it your classroom's camera or your personal camera, that depends on the professor. So whenever you come in front of that camera, you'll click your photo. That will uh, detect you and match your facial features with the image in the database. As it is also having your 10 to 15 images, it will match with that. It will classify you that you are a Google. It will mark your attendance that you were present on that day, that particular day.
Okay, sir.
Yes, Siddharth.
Sir, how do data augmentation techniques improve the performance of deep learning models in image recognition tasks?
Yes. So there are some cases that, like, data collection can be expensive. So after a certain time, it would be very expensive. Like, after collecting some certain data, collecting more data would be more expensive. So for that, we use augmentation techniques. Just as Google talked about attendance system, I'll talk about that only. Like, he only entered 10 images, but I can make it 20. How? I'll, like, if I flip the image this way, then still that person is the same. We will consider it as the same person. So that is the new augmented data. I got from 10 images to 20 images. Now I can make 20 to 40. How? Just reduce it contrast or make, like, increase the brightness. When you increase the brightness, the whiteness, like the pixel value, increases from 0 to 255. So for that, for the model, it is a different image. It will consider it as a different. Yeah, just a minute, Google. It will consider it as a different image, different pixels, and there are so many techniques, like, image consists of RGB channels. We can reduce one and increase other. So that can create a lot of data and can reduce our cost of collecting the data manually. You got it, Siddharth?
So, sir, basically it is we doing some all the possibilities of editing jobs to get more images by a single image.
Yes, yes, yes. It is the manipulation of existing data to create more data.
Now I'm understood, sir.
Yeah, Google, you say.
Yes, sir. I'm also asking same. So we can manipulate the same data and modify the same data, and we can enlarge it to large data set. That's what
Yes,
you
yes,
said,
yes.
right?
Yes,
So
yes.
we,
And that,
yeah. But
yeah.
that can make that more accurate in the solution.
And that will make it more robust because we have more data with the different pixels and different type
So
of
then
images.
it won't be come under overfitting.
No, more the data, lesser the overfitting.
Okay. Okay, sir.
We have the diverse data. That means our model will not overfit much. If we have lesser data, then there are chances of getting overfitting.
Okay, sir. Okay, thanks.
Yeah, that's it. Yeah, yes, yes. So, for past 10 months, I have worked on a lot of models, a lot of projects. So it comprises of a lot of things, just like LLM. How many of you heard about LLM?
Yes, I
Yes.
heard LLM, sir. I heard.
Yeah, yeah. Would anyone like to tell?
Sir, may
Yeah, yeah, you can.
LLM is a large language model which has more sets of data or existing data which is
Mm.
already trained, and we can also train, and we can make it as a dataset which can extract from the database, and it will be more accurate using the neural networks and also using a natural language processing, sir.
Yeah, great, great. So I also worked on that. I built a tool of resume filtering for a job description. So I started with that. Then I went to more computer vision models. I have been working on OpenCV for like past 8 months. Along with I also work on other things like 3D image generations and the talking head generation and some more projects that I am not able to recall right now. Yes, Siddharth.
Sir, one final question. How do you evaluate the performance of a face recognition system in terms of accuracy and reliability, sir?
Yeah, so there are so many metrics to calculate that face recognition, like any model. But for the face recognition, it would be simple. If it is detecting this, then it is like if it detecting the right person, we will assign it as right label and consider it as a true prediction. Otherwise, we will consider it as a false detection. Then, based on that, we calculate precision, recall, and the accuracy. And based on that accuracy metrics, we monitor the model for the face recognition at least. And every model has its own metrics that performs better on that particular model.
Yes, sir. What if the camera resolution is low?
Yeah, that's what I said. I mentioned before. If the camera resolution is different, then it depends on how well you have trained your model. If at the time of training you had that type of videos and images that had lower resolution and higher resolution as well, so if you had a diverse data, then your model will perform well. But if you only trained on high resolution images and then you are predicting using low resolution images, there are chances that model fail.
Sir, if we train our ML model with more data, it could be more effective, right?
Yeah, more robust.
Sir, now I understand. Thank you, sir.
Yeah. Yes, I in Google you were saying something. Yes, I.
Sir, actually, I am working on a project, sir. So I'm actually working on a project which actually involves the usage of drones for identifying the dead bodies in. It is actually based on the collapsed structure search and rescue operations, sir. So in those
Yeah.
hectic situations, we are actually using, in terms of hardware, we are using the microprocessor, which is Raspberry Pi,
Yes.
to connect the main components like lidar, light detection and ranging component, and also
Yes.
we are using ground penetrating radar, and we are also using some other significant components. So when it comes to the AI part, the AI training models, in terms of feature extraction and all, feature extraction, we were actually choosing the histogram of gradients, and also obviously the canny edge detector, which you actually mentioned.
Yeah.
uh, and also when it comes to the AI model, which is, so we actually choose YOLO, and also
Yeah.
recurrent convolutional neural network, and also we choose single shot detectors, sir. So
Yes.
when it comes to resolving budget constraints, the main area that we can focus on this completely is the AI training models. So that is where we actually focus more to
Yeah.
have high speed and accuracy.
Yeah.
So, based on your experience, which AI model based on YOLO, SST, and RCNN, which one has high speed and accuracy, sir?
So I would say, from my personal observation, I would that is YOLO. I have been working on similar kind of project in which like that is a part of big vision, but in which there's some kind of problem statement in which we need to detect the people, majorly the forest officials. Where are they and where are the animals based on the drone? and the vehicle that they are roaming around with that camera images, that night images, we need to detect those people. So YOLO is doing pretty well for that, and that is not expensive. But I would say they have changed their license for the commercial. But if you are using for research, that license is still open. You can use that. Hello.
Okay, sir. But when it comes, one more doubt, sir. Actually, when it comes to the CSSR operations, we would be actually having multiple objects, sir. Apart from dead bodies, we would be having also the collapsed structures, the debris, and also the other objects which would be there. So when the usual scenario which I actually saw in the previous research papers of this project is that they are actually telling that we would be getting somewhat they told localization errors, sir. And also when it comes localization errors would be frequently encountered by when we are using this YOLO. And also they told that the sensitivity to aspect ratio, this is also an important ratio which they were using in this CSSR operation, that is
Mhm.
also somewhat low, they mentioned in the research paper, sir. So based on your experience, how would you see this, sir?
So which YOLO version they were using?
We are using the YOLO version they mentioned is YOLO version 4, sir.
Yeah, but that has been upgraded a lot. YOLO V8 you can use, that is more robust. And if that is the case, like I cannot tell exactly without going deeper in the problem statement. But what I can see is that training might help. Training with that data might help. You need to train it for like larger time, or even if YOLO is failing, then there is one model from Facebook detector on 2. You can also like try that. I cannot tell the exact thing that can be done without looking into the problem statement, but yeah.
Okay, sir. Okay, sir. And also the training. So as you mentioned, the training data quality is higher, no, sir, in YOLO.
That quality I didn't mention. Oh,
But
did I?
we can train larger data sets by using this YOLO, no, sir.
Yeah, yeah, we can train. We can
Okay,
train
sir.
at our custom data, no matter how large it is. Larger the data set, more better is our model.
Okay, sir. Okay, sir.
Yeah, Google.
Sir, yes, as you said about training, can you briefly explain how a training can be done? Because as I know that as I'm a final year, but some of the first years are there. So can you briefly explain some how a training has done like that?
So, my first question would be what kind of training you want to do? You want to fine tune the existing model or train your new model?
Training a new model, sir, so that they
So
can make a new project from that.
yeah,
Yes,
so
sir.
there are some aspects for that. One is most importantly that is data. So you need to
Sir,
get the
actually,
data.
I'm working in a project on SIH, like women safety analytics.
Mm-hmm.
Their first women safety analytics, sir,
Yes,
in
yes, yes.
SIH, a project I'm actually working on. So there is this three scenarios where I should recognize a person direction, then gender classification, also uh, the object direction, sir. I'm coming up with that, so we can take a statement and we can may proceed that, sir.
Okay, so the things that you have told, I would suggest you to go with the pre-trained model because they were trained on very robust data sets. So they have great weights that can be considered. You need not to train it from scratch. So you can fine tune that model. So as much I could know, you mentioned about two problems, that is object detection and another is classification. And that can be done with YOLO only or any other model like said Electron. So for that, how would you do is, if I'm not wrong, YOLO takes 224 cross 224 images. So you will collect the data, and what you will do after collecting the data, you will resize the images as per the required size for the model, Every model has its own requirement, what they want as input, and what are the supporting things. In this, the supporting things will be the txt of the bounding boxes and the labels for that detected thing. So you can go to their repository. They have told about their training steps. So that is very easy to train an YOLO. Just get your data, pass the folder path in their config file, and run python train.py with the config file path. That is very easier to fine tune a model. But if you are talking about training a model from scratch, so first thing would be data collection, pre-processing, and another thing is getting the right model, right number of layers, and code is correct with the model wise. Then you can, if you are training your own model, you can decide your input dimensions and output dimensions, what you want to output, what you want the input. You can change your layers according to that, and after that you just need to train that model by using like PyTorch or TensorFlow, Keras. You can use anything that allows you to define the model and fit with the data and start your training.
Okay, sir.
Anything else?
Still, there's anyone who are interested to ask any questions?
Yes, Yukash.
Sir, I am Vikas.
Yeah.
I have a question.
Yes, ask me.
How has AI transformed industries compared to what was achieved during Industry 1.0?
Your voice is a bit inaudible.
How has AI transformed industries compared
Yes.
to what was achieved during Industry 1.0?
Yeah, that is, I guess, a lot of difference. As honestly speaking, I don't know much about Industry 1.0. So, can you give me a brief about it? What happened in that era? What exactly? Hello.
Yes, sir.
Yeah. Can you give me a brief about Industry 1.0? Anyone?
Yukash, he's asking you to
Yes,
give a
sir.
he's asking you to give a explanation about Industry 1.0.
I exactly not know that.
Actually, I'm a bit unaware about Industry 1.0. Like, I don't know the details about that, so I'm not able to like take the decision. What is the difference? I can
Sir,
tell about the current situation, but I don't know about the Industry 1.0 situation. What was that?
Sir, actually, the Industry 1.0 is actually, which I previously referred you to, proto-industrialization, sir. So this is what is the significant industrial revolution, which actually took place in the, I think, 17th to 18th century, sir. So it is actually the process where the industries were continuously evolving, and the users, mainly the workers, were actually working by creating significant tools to automate their tasks. So this is where the important. For example, I would like to mention the printing press. So
Yeah.
previously, they were actually using calligraphy and handwriting methods to actually write the magazines and other things. But when it came to the proto-industrialization, it is actually the printing press which actually they significantly invented to print the letters, sir. And also there
Yeah.
were other significant tools which were found out during that period, sir. So what Yukash is asking is how AI was there during this era when when it was compared to what was achieved in the industry 1.0, sir.
Oh, yeah. So from this conversation, what I could conclude is Industry 1.0 was more about machineries, and current world is more about the technologies. And in the 18th, 19th century, there was no concept of machine learning. It got popular in late 90s, 1990s. So from that, technologies had taken over a lot of things, and at that time, machineries was taking over the things. So I would say for the artificial intelligence or anything, the basics was the industry 1.0. If machine is not there, would we automate?
Yes, sir. Yes, sir. Yukash, are your doubts clear, Yukash?
As
Okay, okay, Yukash. Okay, still there's anyone who are interested to ask? Yes, Siddharth.
Yeah, there was one
Sir,
more Samiksha, yes, yeah, and Siddharth.
what, sir, what are the challenges associated with the face recognition in real-time video streams? How can they be addressed, sir?
Challenges with face recognition in real time.
Sir,
Yeah, so talking about current models, I don't think there are much challenges. They have covered pretty much everything. If you will look for the latest models, like FaceNet and all, you will see like Google have also launched some model for facial recognition. I'm not I like I'm not remembering the name. I'm not able to recall the name, but they have, and I guess they have addressed pretty much everything. So there are not much challenges left for already existing model.
sir, what if it comes into video inconsistency?
Uh, like what do you mean by that? Video inconsistency?
Uh, sometimes the video we did not be uh, consistent. I mean, it is not clear, or it is have some constraints like light and the clarity, resolutions, like that. So pretty much
You
the
mean if face is not visible properly?
yeah, yes, sir. In the low light, or else.
Yes. So what I know is that facial recognition is a very different thing than other classifications. Like they are classifying between two human and with little features. So image needs to be clear in that case. If like at least human should be able to recognize before expecting machines to be recognized. In the case of face recognition, at least.
Okay, sir. Now I understood.
Yeah.
Sir, and one thing, if
Yeah.
we if we focus on the overview, just like humans have similar patterns in their faces, right?
Yes.
What if we take some records to identify some peoples, like we just take the faces from the records.
Yes.
So what are the challenges in it?
Yeah, what are the challenges if we take images from the records?
Yes, sir.
I guess from the records, images are not that clear, right? So that
Yes, sir.
are
Yes,
not.
I can.
Yeah.
So
So
if the records in the images in the records were not clear, it may pose a false recognition, right?
yeah, it might. So what we can do if the images from the records are recognizable, then we can make a data set of that and train our fine tune our model on basis of that. That is not a big task.
Now understood, sir. Thank you.
Someone else was there anyway.
Sir, good afternoon, sir.
Good afternoon.
Sir, can you briefly explain what OpenCV is and its importance in your application today?
Oh, yes. So OpenCV is computer vision library. Like we are talking about everything. If you want to use classification, object detection, segmentation, and just like edge detection, so for doing it manually you need to get a model for everything, every script, and then test it. What OpenCV does, it has built its own code base in which they are importing from, they are taking that code for you and give you just a class name. Using that class or single or two three line of code, you can directly access those models without doing it manually for each case. In a project we might need to do so many things like detection, classification, and I would say as detection or anything. So rather than keeping files for every model, you can just install the OpenCV library that provides you all the things they have in their code base. They constantly keep updating that, and it is basically keeping the famous computer vision model in their code base that makes it easily accessible for common people like us.
Okay. Then what
Very
are
clear?
examples, real world examples, sir?
Sorry, I'm not able to hear you. Can you please speak louder?
Sir, what are some real world examples of OpenCV, sir?
I still couldn't get. Can anyone explain what is he saying?
Jamna, can you actually repeat the question once again?
Now, what are some real world examples of OpenCV? Now?
What are the
Jamna, if
major
you're
disadvantages?
Real world examples.
real world
Sir,
example,
real world examples, sir.
real world example of computer vision. So yeah, everyone like in every case it is getting used. Just to say, if like what should I say the real world example? OpenCV is getting used in the projects, so it has, it don't have its own real world significance. You will use it in some project, just like as Google told me about an object detection model he is trying to train. So for processing the data, you can use OpenCV like preprocessor that is blocked from image. And if you want to perform the detection, you can also use OpenCV's model that is not much robust model on your own data. That if your data is differing from general data, then it will not perform well. For that you need to train the model. But for general cases, OpenCV provides a lot of model pre-processing techniques and a lot of things. Pre-processing is a library that is used in building projects. Yes, Sangeeta.
Okay, sir.
So I have a question. I'm a
Yeah.
first year student. Actually, OpenCV is used in satellites, I think.
Yeah, it is getting used in everywhere. That is like what I'm trying to say. It is a library. It has its own code base. That code you can use to build anything.
Okay. So actually in satellites, we are using Google Maps like that. It recognizes the road and the bridges, etc. like things. Then how do we avoid the noises like when it's time of raining? How would
Yes.
avoid the sound of the rain noises by the AI like that?
So there are so many techniques, and that is a really big problem that is being addressed with a lot of methods. So there is no one word answer for this, but you can use just like smoothing, noise, Gaussian noise reduction filters, and there are so many models trained for that. And there you can use like a particular place is raining for a certain time only. Before that it was clear, after that it will be clear. So you can use image reconstruction, that what would it be looking like at this time. You can
Okay,
remove the
sir.
rain noise with the help of previous images, current images, and reconstruct the current image. That is a vast problem.
Okay, sir. And one more thing, sir. If a road is extended and it is not updated in the Google Maps, then how will people will find it is the extended road and it is not like that?
Yeah, yeah, that's the job of Google Map team to update the images, update the map, update their map with the help of satellite images updation.
Here I'm
So
asking what are the technologies used here?
yeah, that is a different concept.
Oh, okay.
Yeah.
But it is has a
Like
recognition of face detection and the direction of imaging like that. So what that one you have asked.
no, 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 that is not like that. If images are updated, road is built, then Google Map team will take that and add into their mapping application. That is a different task.
Um, okay. Thank you, sir.
Anything else? Not for now. So I guess we can conclude it. If anyone is having any question, you can reach me out on my LinkedIn or my email. I'll try to answer that. So Dakshin, can we conclude it for now? Hmm. Pardon, please. Yeah, your voice is a bit inaudible. Yeah.
Spark. Yes, sir. Good evening, sir. Good afternoon,
Hmm.
sir. This is
Hmm.
Bhanupriya, Assistant
Yes.
Professor from EC Department, sir. I am the
Hmm.
faculty
Yes.
in charge for the Blockchain Club.
Yes.
Thank you so much for your valuable experience and sharing your everything, sir, and clarifying the doubts for the students, sir. Thank you so much for joining this webinar, sir.
Yeah,
Thank you, sir.
thank you so much from your side as well. It was a nice interactive session.
Okay. Over to Dakshin.
Good afternoon, everyone. On behalf of the Boston Club, I would like to take this moment to extend my heartfelt thanks to our guest speaker, Mr. Abhishek Gola, our esteemed guest for sharing the valuable insights on computer vision. We greatly appreciate the time and effort invested in preparing such a thought-provoking presentation. Your experience have left a lasting impression on all of us. A special thanks to our Blockchain Club President Dhanasilanna, Secretary Sandhyaka, CSO Tamilmani Hariharan Anna, the Vice President Saidinesh Anna, Deputy Secretary Dakshan, and all core committee members for facilitating today's session, and of course to all the participants of your engagement and attention. Once again, thank you, sir, for gracing us with your presence and knowledge. We look forward to more such enlightening sessions in the future, sir. Thank you, sir. Thank you, everyone.
Yeah.
Sir,
Okay
our
then. Yeah, yeah. See.
sir, you can continue.
No, no. You can continue. I was not saying anything important.
Yes, sir. I would like to express my deep thanks, sir.
Yeah.
क्योंकि मेरी ओर से आपने जो भी वेबिनार सेशन दिया और आपने सारी स्टूडेंट्स की डाउट को आपने सॉल्व किया, इसलिए मेरी ओर से आपको एक हार्दिक शुक्रिया, सर.
Welcome. Welcome.
Yes, sir.
Thank you. Yeah. So I would like to take your leave now. Thank you, everyone. It was a great session. See you. Bye.
Thank you,
So
sir.
much.
Yeah, bye.
Thank you so much, sir.
Yeah.
Thank you so much, sir.